This is crazy. Literally, we have just witnessed history in aerospace engineering take a major U-turn. Forget for a moment about rockets landing smoothly on 4 legs on a barge, the style SpaceX has accustomed us to. What China has just achieved is pure science fiction. They dropped a 5-meter diameter cylinder from space and caught it in the middle of the sea using a network of tensioned steel cables. And they nailed it. It has been a resounding success. Welcome back to Próximo Framework. The inaugural flight of the Long March 10B rocket has just been completed. And not only did they put their payload into orbit without breaking a sweat, but they also achieved that crazy milestone the entire industry had been talking about for months: the offshore recovery of the first stage by capture. In this video, we are going to see exactly how this flight went step by step, because the mission profile is one for the books. We'll break down exactly what this rocket is, why it has a methane stage, what that incredible autonomous vessel called Linghangzhe is that they use to catch it, and above all, why they decided not to copy Elon Musk and instead bet on such a different recovery system after the failures they had last year. To understand the magnitude of what we've just seen, I want us to go over the entire flight because it was a spectacular choreography of engineering. It all started at commercial launch pad LC2 at the Wenchang Space Launch Site on Hainan Island. Take a look at the location, because launching from Hainan is no coincidence. They are very far south, close to the equator, which gives them an extra boost from Earth's rotation to maximize payload capacity. Plus, they have the South China Sea right in front of them to pull off these crazy maneuvers without putting anyone on land at risk. The liftoff was brutal. We are talking about a beast nearly 70 meters tall with a mass of about 540 tons that rose from the pad powered by 7 YF-100K engines, all igniting at once, spewing fire and generating around 892 tons of thrust. The rocket climbs, passes through the moment of maximum dynamic pressure, the famous max Q, where the structure undergoes the greatest aerodynamic stress and keeps going up as if it were nothing. Then comes the key moment, stage separation. The engines of the first stage shut down, what we call MECO, and both halves separate cleanly. From this second on, the mission splits into 2 parallel stories, and both had a happy ending. On one hand, the second stage ignites its engine and continues its way into orbit to deploy the payload. By the way, this payload, as is very common in these Chinese demonstration flights, was an absolute mystery. But the important thing is that the orbital insertion was perfect. Primary mission a success.
But of course, all eyes were on what was happening below. Look at this, imagine the scene. The first stage, a gigantic tube 5 meters wide, runs out of thrust and starts falling back toward Earth. The first thing it does is use its small coal gas thrusters to flip itself around. It needs to enter engine first to withstand the heat. It reignites some of its main engines to slow down the impact against the densest part of the atmosphere, which we know as the re-entry burn. And this is where aerodynamics comes into play. 4 grid fins deploy at the top. If you've seen a Falcon 9 land, you know what I'm talking about. They are like giant cheese graters that move to steer the rocket as it falls at hypersonic speeds. The rocket is aiming for a tiny point in the middle of the ocean. Close to the surface, the rocket fires its engines again for the final landing burn, braking almost to a halt, neutralizing all its vertical and horizontal velocity. And here comes the heart-stopping moment. Instead of deploying legs, the stage deploys recovery hooks located in the inner stage area. Just below it, there is no flat barge. There is the Linghangzhe, a vessel with a dozen super-tensioned steel cables. The rocket descends, the hooks catch the cables, lock in, and the tension of the net absorbs all the kinetic energy left in the rocket. Boom. Captured. It hangs there, suspended, quasi-vertical, without tipping over and without touching solid ground. I promise you that seeing how a mechanical system absorbs the impact of tens of tons falling from the sky without anything breaking in half is an absolute triumph of material science and automatic control. But let's wind back a bit. What exactly is this Long March 10B, and why is it so important for China? This launcher is not an isolated project. It's part of a huge family, the Long March 10 family, developed by the China Academy of Launch Vehicle Technology, CALT. The ultimate goal of this rocket family is to take Chinese astronauts, taikonautas, to the moon before 2030. They have a giant 3-core version for the moon, a single-body version, the 10A, to go to their Tiangong space station, and then there's this one, the 10B. The 10B is the commercial variant. It is the ace up the sleeve of China Rocket, the state-owned commercial subsidiary, to compete head-to-head in the international market, specifically against SpaceX. We are talking about a rocket that can put 16 tons in low Earth orbit while being reusable, or up to 27 tons if they decide to discard the rocket into the sea. These numbers put it directly in the same league as the Falcon 9 Block 5. But there is a technical detail of this rocket that blows my mind and proves that the Chinese are not just copying, but iterating. Look at the second stage. While the 10A model uses kerosene in its second stage, the 10B uses methane and liquid oxygen, what we call methalox propulsion, with a YF219 engine that delivers 140 tons of thrust. Why methane? Because it is the future. Methane burns much cleaner, leaving almost no soot residue in the engines, which is vital if you want to reuse that second stage too one day. It aligns with what SpaceX is doing with Starship or Blue Origin with New Glenn. And by the way, I don't know if you've noticed in the images, but the design on that second stage is amazing. They have painted a red, C-shaped dragon inspired by a jade from the Neolithic Hongshan culture dating back 6,000 years. A brilliant design touch to symbolize the pioneering spirit.
And speaking of pioneers, we have to talk about the vessel that made this miracle possible, the recovery ship. It's called Linghangzhe, which literally means the pioneer, or the guide navigator. It is not just a floating barge, it is a masterpiece of naval engineering delivered in late 2025. It measures 144 meters long, 50 meters wide, and displaces 25,000 tons. And the craziest part? It is an autonomous ship. During the capture phase, it positions itself and maintains its station in the middle of the sea without an active crew on board, to avoid human disaster if the rocket decides to fail and fall like a stone. In addition to the cable network, it has an articulated mechanical arm in one corner. Once the rocket is caught in the cables, this arm moves in, hugs it, stabilizes it completely, and helps to passivate it. Passivating a rocket means draining the remaining fuel and relieving pressure from the tanks so that it isn't a ticking time bomb during the journey back to the port of Sanya. Everything thought out to the millimeter. I'm sure many of you are wondering, if SpaceX has been landing rockets on legs with smashing success for almost a decade, why is China overcomplicating things by inventing a catch system with steel cables? It is not just to be different. It makes complete sense from an engineering standpoint. Think about it. Mechanical landing legs, with their shock absorbers and deployment systems, weigh a ton. They are tons of dead weight that the rocket has to carry up into space and then back down. If you eliminate the legs, you save a critical amount of mass. That weight savings can be turned into more fuel margin, or even better, into more satellites you can charge clients for. Also, a net or cable system is, in theory, more tolerant of minor precision errors. If you land with legs and one of them steps outside the reinforced zone, or the barge moves because of a wave, the rocket tips over and explodes. Here, as long as the hooks catch the cable area, the flexibility of the system itself absorbs the error. They have integrated all the complexity into the ship, leaving the rocket as light and simple as possible. And believe me, they needed this to go well after the failures of Landspace and the Long March 12A in late 2025, which made many say that China was 10 years behind SpaceX. That's why today's success with the Long March 10B, prepared with a brilliant suborbital test in February, was vital for their prestige. With this, China demonstrates mastery in medium-class reusability and becomes the second country to operationally recover an orbital stage, opening up real competition for SpaceX. Although this specific booster will be completely disassembled for in-depth study instead of flying again immediately, the milestone crucially validates the technology they will use in their future crewed lunar program. All in all, today is a historic day for space exploration. Engineering never ceases to amaze us, and seeing different approaches to solve the same problem, legs versus cables, is what makes this sector so exciting. I would love to know what you think about all this. To what extent do you think this cable system is scalable for larger rockets? Do you think China will manage to reach the launch cadence that SpaceX has right now? Leave all your theories in the comments. You know I always read you and love to debate down there. That's all for today. If you like this analysis and want us to keep bringing you space news explained in detail, you know what to do. Smash that like button, subscribe if you haven't already so you don't miss the next video, and leave in the comments what topic you'd like us to cover on El Próximo Framework. See you all soon.